I want us to talk about a horizontal asymptote. The line y equals to b is a horizontal asymptote of the graph of a function f if f of x approaches b as x increases or decreases without bound. I want us to talk about a horizontal asymptote. I want us to look at graphs that involve horizontal asymptotes. In your online homework, you're asked to tell the horizontal asymptote. So look at this problem. This is f of x equals 2 to the x power. In the past, we used a table to graph this graph. We see that this graph is getting closer and closer as we plug in numbers that are negative. -1 was about a half, -2 maybe a fourth, -3 maybe an eighth, and it just keeps getting closer and closer and closer to the x-axis, but it actually never touches the x-axis. So I'm going to draw a dotted line to signify that this is the horizontal asymptote. Okay? So if you are asked to tell the horizontal asymptote of this problem, it is a horizontal line. Every horizontal line you name with just a y equal to a number because it's touching the y-axis here. So the name of this horizontal asymptote would be y equals to 0. Okay? So when you're asked to find the horizontal asymptote of an exponential graph, this particular one was y equals to 0. You're also asked to tell the domain and the range of this function. Remember, domain is all of your x values that have been used to graph this function. So when I look at this graph, what x values have been used? Well, as I start my pencil over on the left, I see that my graph would touch my pencil. Every x value has been used as I start from the left, -infinity. This graph goes on and on and on, using every positive x value as well. So your domain in this problem would be from -infinity to +infinity. Every x has been used. Range is your y's. Domain is your x's. Range is your y's. What y's have been used? Well, as far as your y's go, none of the negative numbers have been used, starting with 0, but actually 0 is never touched, so it's going to be everything greater than 0. 1 has been used, 2, 3, 4, so forth on. Your y's start at 0 and up, but they do not include 0. So I would need to put a parenthesis around 0 and +infinity. Because 0, it has never touched 0, because this graph, we have an asymptote. It gets closer and closer and closer to the x-axis, but never touches it. So this would be your range from 0 up, but not including 0. Now, let's recall, if I was to ask you to graph f of x equals 2 to the x power minus 3. Okay? Well, this is your original, and I'm wanting you to graph 2 to the x minus 3. Anytime you add or subtract a number to the back, that is a vertical shift. So let's move everything down 3. Coming down 3. 1, 2, 3. Moving this point down 3. 1, 2, 3. This one down 3. 1, 2, 3. This one down 3. Getting closer and closer. This one down 3. 1, 2, 3. Down 3. 1, 2, 3. This one down 3. 1, 2, 3. So here I have this graph of the translation of a vertical shift down 3. Okay? So let's talk about this one. What would be my horizontal asymptote of this problem? Well, this graph is getting closer and closer and closer to this line, but it never will touch this horizontal line. So of this translation graph, what would be your horizontal asymptote? Well, it would be y equals 2. You're down at 1, 2, 3. Y equals to 3 is your horizontal asymptote of the translation, the one shifted down 3. So what would the domain be? And what would the range be? Well, again, every x is being used as we go to the left, as we go to the right. So your domain, again, is negative infinity to positive infinity. What is your range? Where does your range start? Well, it's getting closer and closer down to 3, but it doesn't touch 3, negative 3. But it's everything greater than negative 3. When I look at my y's that have been used to graph this, I use negative 1, negative 2, 0, positive 1, all these positives. But as far as it goes all the way down to negative 3, but does not include negative 3. So your range would be from negative 3 to positive infinity on the graph that I had a translation of shifting it down 3. So now we have talked about the horizontal asymptotes and the domain and range. So now you should be able to do your online homework involving graphing functions.